this is work I did with my co-authors, Anna and Luke, who are also in the audience. So yes, firstly, this is stuff that most of you will be very aware of. But there's been lots of talks, lots of scholarship, lots of journalism about issues of gender bias and what kind of associations with gender are embedded in language models. So here you can just see some of examples, but I'm sure all of you are aware of many, many more. In this work, we are looking at two things which haven't been really studied as much in all of this literature, which is firstly the association between gender and sex in language models, and secondly, pathologization, so association with illness based on gender identity in language models. And the reason that we are looking at this is that in gender studies literature, gender theory literature, so for example, you can think of like Gender Trouble by Judith Butler as maybe one of the most influential famous books in gender theory. These two themes of the relationship between sex and gender and also pathologization based on gender identity are very, very important. But in the computer science literature on language and gender, these themes aren't really talked about as much. And in some examples, so for example, here you have the Man is to Computer Programmer as Woman is to Homemaker paper by Boluk Bazi, which was like super influential, such a cool and important paper about looking at gender bias in language models. They, for example, have this stems from their paper, so that they are looking at associations between gender and occupations. In the first example here, so they're finding that the vector between man and computer programmer is very, very similar to the vector between woman and homemaker. And they find this to be a problematic stereotype that they would want to remove from models. They also have a whole set of examples of associations with gender that they explicitly want to keep in the models. So this is, for example, he is to prostate cancer as she is to ovarian cancer. So the fact that these two vectors are similar, they're defining as good, and then they're developing a methodology for removing the problematic bias while keeping the appropriate bias in the language models. But looking at the gender studies literature, we might question whether really the second one is appropriate either. So now what we are doing is looking at the association between gender and sex. Here it's just one example. So you can see here the person who has testosterone is versus the person who has estrogen is. So these are two sentences that we are feeding into the models. And then we are looking at the probability of any of these gendered terms as completion. So we have is a man, is a woman, is transgender, is non-binary, is genderqueer, is gender fluid, or is two-spirit. And we are seeing here that the typically male sex characteristic testosterone, the probability for a man is the highest, is the completion, versus for estrogen, which is typically female, the probability for a woman is the highest in the language models here, according to Llama 70b. So these are normative associations between gender and sex. We find that the probabilities for example, transgender, non-binary, and these other terms are quite significantly lower. And keep in mind that this is a log scale, so they really are quite significantly lower. But just from this figure, it's kind of difficult to see if they're maybe lower but still seen as meaningful completions of this prompt, or if they're lower because they're not even seen as like making sense in this context at all by the language model. So in order to figure this out, we created a random baseline where we generated 50 completely random nouns, and then we removed all nouns that were at all related to humans from this list. So we were left with 47 completely random non-human nouns, and we checked their probability of being the person who has testosterone is, and then, for example, watermelon, or a completely random non-human noun. And here you see the lines of the median of the probability of all of these completely random words. And you can see that that median sometimes is even higher than the probability of completing genderqueer in this context. And keep in mind that these are words that don't even make sense in the context at all. So we more think that these types of gender terms that are not a man or a woman in this context are seen as not really making sense at all. We can see that this trend also does seem to hold across different models that we tested. And we can also see that it does appear to hold across different sex characteristics. This plot is in the paper, so I know it's a bit overwhelming on a slide, but you can check out the paper to look at it in more detail. We are also interested, as apparently also some people in the previous presentations were, on how this would change across model scales. Because you could think, as models get a lot larger, they might have more nuance, or they might have the capability of learning more nuanced associations between gender and sex. So for this, we calculated a Folk subversive log probability ratio. For methodological details, you can check out the paper, but what you really need to know is that the more positive this ratio is, the more probable it is that it will make a kind of normative prediction of a gendered term depending on the sex characteristics mentioned in the context. The more negative it is, the more likely it would be that it makes a subversive prediction depending on the sex characteristic of the context. So what we see is a pretty steady trend that, depending on model size, larger models appear to be learning these associations between gender and sex more and more strongly, and appear to be having stronger and stronger associations between gender and sex. So then, secondly, we're also looking at the pathologization based on gender and sex when it's not binary. So this is talked about a lot in gender studies literature, but here you can also see kind of some common examples. So for example, gender identity disorder is seen as a medical diagnosis. There are narratives framing gender diversity as mental illness. There are medically unnecessary operations performed on intersex bodies. So here you can see that like gender and sex, which doesn't fit into this gender binary, is medicalized often across society. We are again calculating a log probability ratio where you can see the details in the paper, but we are here always looking at the probability of predicting an illness-related term, either mental illness or physical illness-related term. The more negative it is, the less likely it would be that this illness-related term is predicted in a context with non-binary compared to a man. The more positive it is, the more likely it would be for non-binary compared to a man. And we see here that for mental illnesses, the distribution is shifted really to the positive side. So it is a lot more likely to generate mental illnesses if the context mentions non-binary compared to a man. We can see that this trend also holds broadly across different models and across different gender terms. There's some variety between, specifically for a woman, there's some variety for different models, but for the other terms, it seems to be pretty consistent that mental illness is more associated with gender diverse identity terms. So overall, our findings reveal that models learn normative associations between gender and sex. Specifically, as they get larger, they learn these more strongly, and that they pathologize transgender and gender diverse gender identities as being related to mental illness. My personal main takeaway would also be for everybody here in the room that if we do kind of computer science work and we think about these social categories like gender, but this also holds for different types of social characteristics, to not forget that we don't have to reinvent the entire wheel. There's so much literature in the social sciences and the social theory about all of these categories and about all of these social phenomena, and it can be really, really helpful to check out the relevant social science literature in order to get maybe a more nuanced perspective and understanding of the social characteristics that we're talking about. So thank you very much, and I guess questions at the end. Good.